differentiating exponential functions. Our objective is to differentiate all exponential functions of the form y equals a to the x, where a is any number greater than 0 and not equal to 1. Let's recall the properties that e to the natural log of x, the inverses, composition of the inverses equals just x. E to the natural log cancels and leaves us with x. Also, the property that the natural log of a to the x can also be written as x times the natural log of a. Why? Remember that property where we can move the exponent of the thing in the log to the front as a coefficient? That's right. So now, let's consider the following property of logarithms. A to the x is equivalent to e to the natural log of a to the x, that's using that inverse property, which is equivalent to e to the x times natural log of a, which is using that property. Therefore, it follows that the derivative with respect to x of a to the x is the same as saying the derivative with respect to x of e to the x times natural log of a, since a to the x is equivalent to e to the x natural log of a. Well, if we think of this as a composite function where this part right here is the inside, that's our chocolate, u is x natural log of a, then when we take that derivative, it looks like this. E to the u times du dx. What does that look like? E to the x natural log of a times the derivative of u with respect to x. Well, because natural log of a is a constant multiple, the derivative of u with respect to x is just the constant multiple natural log of a. So times natural log of a. This, of course, is equivalent to a to the x. So this is the same as saying a to the x times natural log of a. And there is our derivative of any exponential function y equals a to the x. Ultimately, whether or not you remember how to get there, let's remember what it is. The derivative of y equals a to the x, where a is greater than 0 and not equal to 1, is a to the x times natural log of a. Memorize this. Find the derivative of each function. If f of x equals 2 to the x, this is following that exponential model. 2 is greater than 0 and not equal to 1. Then f prime of x is simply 2 to the x times natural log of 2. A to the x natural log of a. 2 is our a. And that's it. How about this one? If capital F of x equals 3 to the negative x, well, we could rewrite this because this is the same as saying 3 to the negative 1 to the x, because these multiply, which is also the same as saying 1/3 to the x. If I'm doing the derivative with it written like this, that would be the a, 1/3. So this is going to be 1/3 to the x times natural log of 1/3. Definitely an acceptable answer. But remember where this came from was originally this. So I could also write this as 3 to the negative x n times natural log of 3 to the negative 1, also a good answer. And I could also move the negative 1 into the front and write negative 3 to the negative x times natural log of 3. With logarithms, you have to be aware of all the different possibilities that the answer could look. Let's find the derivative of g of x, which equals 1/2 to the x squared plus 1. Now, this is a composite function where this is the inside, my u. U is x squared plus 1. So I can rewrite g of x as 1/2 to the u and use my chain rule. Using the chain rule, the derivative of g prime of x, is 1/2 to the u times natural log of 1/2. That's the derivative with respect to u, but then of course I need to multiply times du dx. That was only the outside part. The du dx is the inside part. So now let's do some substitutions. 1/2 to the x squared plus 1 times natural log of 1/2, and then du dx, the derivative of u with respect to x, is 2x. And we have a derivative. Now again, we want to remember that there's some cleaning up we can do. So let's try. 1/2 to the x squared plus 1 can also be written as 1/2 to the x squared times 1/2 to the 1. Excuse me for that, because when we multiply, we add the exponents. Natural log of 1/2 can be written as natural log of 2 to the negative 1, and then of course we have 2x. Well, why was this helpful? Because 1/2 times 2 is 1, so that cleans that up a bit. And then I can move this negative 1 as a coefficient. So while that is an acceptable answer, I can also have negative natural log of 2, and then I've got an x and a 1/2 to the x squared. Also a very good answer. Thanks for watching.